In this video, we start off with analytical geometry for grade 10 by having a look at the distance formula. Analytical geometry is the study of geometry on a system of axes. This means that we can now also make use of algebra because each point in the sketch has a coordinate that goes with it. So here it is important for you to remember that the horizontal axis is our x-axis and the vertical axis will be the y-axis. So to describe the position of any point on the system of axes, we are going to start off describing its position in terms of x, and in the case of A, that will be at -2. Then we say where it will lie in terms of the y-axis, and for A, that will be 2. In this chapter, we're going to have a look at different calculations we can do using coordinates on a system of axes, as well as the conclusions we can make from those calculations. The first calculation we're going to have a look at is how to determine the distance between 2 points on the system of axes. Let's say we want to determine the distance from B to C. These 2 points lie in the same horizontal plane. Therefore, we can simply focus on where they lie on the x-axis. B lies at 1 and C lies at 4. And from here you can see that the distance between the two is 3 units. Next, let's determine the distance from C to D. These 2 points lie in the same vertical line. Therefore, we can focus on their y values. From a y value of -1 to a y value of 5 is a distance of 6 units. This distance indicates the difference between the two y values. So the difference means minus, and we are going to take 5 and subtract -1, which will become 5 plus 1 and give us the distance of 6. What if next up I ask you for the distance from B to D? This is not a horizontal or vertical line. Can you see that this line lying at an angle forms the hypotenuse of a right-angled triangle? This means we can determine this length by making use of the theorem of Pythagoras. So we can start off by taking BD squared and putting this equal to the sum of the squares of the two shorter sides. So BD will then be equal to the square root of 3 squared plus 6 squared. This is then the square root of 45, which will give us a length or distance of 6,71. Here we had a slow progression in the 3 questions. But what if I did not give you point C and immediately asked you for the distance from B to D? To determine the distance of a side that is skew like this, the easiest is to go and add that coordinate that is horizontal to one point and vertical to the other. Then we know that it has the same x value as one of the points and the same y value as the other. Then you can follow these same 3 steps to determine the length of the skew line. Luckily for us, all of this is already put together in one formula called the distance formula. Here you can see that they are making use of the theorem of Pythagoras. The first bracket inside the root is the horizontal distance between the two x values of 1 and 4. Then we have a look at the second bracket, and the second bracket gives us the vertical distance between the two y values. So instead of doing all these separate calculations, you can always simply substitute your 2 coordinates into the distance formula. Let's try it out and determine the distance of BD. We are going to start off by calculating the difference between the two x values. The x values we have is 4 and 1, so it will be 4 minus 1. Next, we're going to calculate the difference between the two y values of 5 and -1. Remember that you need to get the difference between 5 and -1, and it is therefore important to put that -1 in a bracket. And now we have the square root of 3 squared plus 6 squared, just like we had using the theorem of Pythagoras to get to the same answer of 6,71. Example 1. In the sketch is A, B, and C. Is this an equilateral triangle? An equilateral triangle has 3 sides of the same length. Therefore, we need to get the distance of AB, BC, and AC to determine whether this is an equilateral triangle. For this, we're going to make use of the distance formula. Firstly, for the distance from A to B, I'm going to focus on the coordinates of A and of B. Here it doesn't matter which point you choose as your point number 1 and 2. I chose B as 2, so I'm going to start substituting the x values with B going first as 1, and then subtract that of A, which is -2. And the same for the y values. I'm going to start with the y value of B and subtract that of A. And if you put this into your calculator just like that, you'll get the value of 5,83. Now I'm going to repeat this for the distance BC, and here point C will be my x and y1. So when I substitute, I start with the x value of B again and subtract that of C. Now for the y values, I take the y value of B and subtract that of C. This will be a distance of 5,66. And finally, we're going to do this again to get the distance from A to C. Here I'm going to choose to make point C my x and y2. This distance is 7,07. Now we can see that all 3 side lengths are different. Therefore, my final conclusion will be, no, this is not an equilateral triangle. In the next video, we'll have a look at how we can use the distance formula to answer different questions.